Now what about, we will have to apply the situation. If L is equal to N, if L is equal to N, like these two indices are the same. L is one index, any value 1, 2, 3, any value it can get. N is an index 1, 2, 3. So if these two indices are the same, then this will come out to be equal to 1, and this will make, and what about here? Okay, understand this step. If L is equal to N, then this delta function will become 1, and this will come out to be En 1. What about here? If L and N are the same, then this is Nm, but we know M is not equal to N, so this will become 0, right? And what we will get? En1 will be equal to this one. So if L is equal to N, then delta Lm will become equal to delta, this will become delta N and Ln. So this is N and M. But we know M is not equal to N here. So this will come out to be 0. And we will get this whole number become 0. This will come here and become plus. And we are having this thing equal En1 is equal to psi L0 and H prime psi N0. Okay, this is En, so I will write this L equal to N. And what is this? This is the first order correction to the energy. We have already derived this one. So it means L equal to N is not giving us anything new, but the old result that we have already derived. And what about if L will not be equal to N? If L is not equal to N, then we get here summation on M not equal to N. Okay, and this thing, you are now having L not equal to N, so we will have EL 0 minus En 0, because L is not equal to N now. So these two are now not cancelling. And then this will become Cm, this will become Cln, because the M will become equal to L. And this is equal to psi minus here. And when L is not equal to N, so this value becomes 0. We got rid of this term, only this term remains, and this will be minus psi L0 H prime psi N0. And now from here I can write the CLN value from here, and the CLN value will come out to be psi M0. Now I can write this one if I want to write in the summation form. Look here, you are having L here, you are having N here. Okay, one thing, we will have to just remove the confusion here. Don't write the summation here. Then You are having L0 and N0, two values. Here L and N, here L and N. So if I want to write this thing in the summation form and M is not equal to N, then I can write summation on this is will become Mn, because here I am using Mn, so I will just go back to those values. And I can write that CLN is equal, CLN from here is psi L0 H prime psi N and 0, this value divided by okay, look here, minus sign is here, so if I reverse their order, then that minus will be compensated, and I can write this one is En0 minus El0 for Ln. Now if I want to change this back to M, then what it will be? It will be Cmn is equal to psi M0 minus psi M0 H prime psi N0 divide by E N0 minus E M0. Clear? So Cmn I have found. As I have found Cmn, I will now put the values here. So from here, from this equation, psi n1 is equal to the summation on m such that it will not get this index n, and psi m0, this is the Cmin value, psi m0 h prime psi n0 divide by En0 minus em0 and put psi m0 here. So this is the Cmn value, and this is the first order correction to the wavelength. Now you can understand, you can interpret this further. This is the correction, first order correction to the wave function. Now the correction depends on the value of perturbation. Perturbation you will apply on the unperturbed one state, and then you will multiply it with another unperturbed state divided by their respective energies of those states. Whatever comes from here, you will multiply with the unperturbed state, right? So it will give you some value, the wave function will be gone. This is just a number, it will come out to be a number, it is a number, and the wave function, so dimensionally the wave function on both sides. And this is the first order correction. In order to remember this thing, it is easy. Psi m0, psi n0, and h prime is there. Their energies will be reverse of it. En0, em0, because we have compensated that negative symbol, and multiplied with psi m0. Whatever wave function you are having here will be psi m0 here, and it will be the first order correction to this one. Now keep in mind one thing, m and n, they are just indices. Like this is, let's say n is no 1, so 1 1, m will be 1 2 3 and so on. Summation is on m, it will not get the value n, like psi 1 is here, so this will never be psi 1, it will be psi 2, psi 20, psi 30, psi 40 and so on. That one value it will not get, because on that we have done those calculations. Similarly, it is very easy to find out the second order correction to the energy, and we will find that one as well. Now we will find the second order correction to the energy En2, and for this we will again consider the first order equation, and that equation is H0 psi n1 H0 psi n1 plus H prime psi n0 plus H prime psi n. So we will consider the second order equation here. So this is 2 here and this is 1 here. This is the second order equation that we will consider is En0 psi n2 plus En1 psi n1 plus En2 and psi n0. We need En2 now. En1 we have already found. We don't need to find En0. En0 is already the solution. So now again we multiply with psi n0 conjugate, right? Multiplying this thing with psi n0. Why psi n0? Because I want to get this value. So in order to get the value of En2, we will multiply this with psi n0. So do multiply it with psi n0, and what I will get? I will get H0. This is H0 psi n2, and then I multiply it with psi n0 plus psi n0 and H prime psi n1 is equal to, I will just write it outside because I know it will come ultimately outside. So psi n0 and psi n2 plus En1 and psi n0 psi n1 and plus En2, and psi n0 into psi n0 will come out to be equal to 1. So I am not writing it in that form, but it is like this. Now what about this one? I can write this one as H0 psi n0, and it will become En0 psi n0 into psi n2, psi n0 with psi n2. Keep this in mind. Come here. It will become En0 and psi n0 psi n2. So this one and this one are cancelling, is like previous. Got it? If it's not clear, let me repeat. I can move this one here, so it will become H0 psi n0. When H0 on psi n0 is operated, it will give you En0 here and then psi n0 and psi n2. And it is here En0 psi n0 psi n2. So these two are cancelling here, and we are left with this one, that psi n0 and this one En plus, okay, the other terms. Look here, this one has already become 1. So we are left with these two terms on this side, one term on this side. So I will have to find out this one. And now what this will give me? This will give me H0 sin n0, and let me write this one En2. This implies that En2 is equal to psi n0 H prime psi n1, and this one, when this will come here, it will become minus, and En1 psi n0 psi n1. So we will have this one. Now I already know about psi n1 from here. Psi n1 is equal to this. Psi n0 n h prime, psi n0 n minus this. And what about this one? If I write psi n0 is here, and I write for this one psi m0, because this psi m will multiply with this when I will write psi n1 over here, then this is having some terms here, and then psi m0 is here. So that psi m0 will multiply with this psi n0. That psi n0 and psi m0. It will come like this, plus this term, whatever is this one, it is here. But here is a summation, and summation is saying m is not equal to n. And here m and n are here. So if m is not equal to n, then this will go to 0. So it means that this term is going to 0. And I get this situation is en2 is equal to, for one term, this one is giving 0, but I will have to put this value here as well. So en2 comes out to be equal, en2 comes out to be equal summation on m, one value excluded, n, and this is psi m0. Let me first write this one, and then I will write, let me first write this one, psi n0 h prime psi n1. And now for psi n1, put the value. You got this point that this one will come out to be 0. I will now put for psi n1 this whole value, and this will be equal to, let me just not write this one at the moment, because I just skipped to write psi n1 directly. Now I will put psi n1. So put psi n1 this value here, then what it will be? When I will put here psi n1, then in psi n1 itself these two are being multiplied. So they will be there, while psi n0 will multiply with psi m0 here. So I can write this one is equal, en2 is equal to summation on m not equal to n psi m0 and h prime psi n0, then psi n0 and h prime psi m0, whole divided by en0 minus em0. And this is the second order correction to this one. Look here. This is psi n0, h prime, and this psi m is actually this one, right? So it is done, while psi m0, h prime, psi n0 is our this value. So we have written it like this. Now another thing that we know here is psi m0 here, psi n0 here, and psi n0 here and psi m0 here. So it is just a matter of indices. Like m and n are indices. We can shuffle them. They are just numbers, n1, n2, and so on. So I can write them in a compact form like this. En2 is equal to summation on m for not equal to n, and the absolute value of this psi m0 and h prime psi n0, and this will become mod square divided by en0 minus em0. Now look here, what I have done here. This one, if I shuffle them, like psi m come here, psi n come here, it will become conjugate, right? And that conjugation will make this thing mod square. Like the conjugate and the non-conjugate will make mod square, and this is the second order correction to the energy. And this one is comparatively easy to remember. Here you are having the perturbation, the unperturbed states m0 n0, and then their respective energies, but in a reverse order to this one, right? And this gives you the second order correction to the energy. Hopefully in the next we will start with more, you can say, calculations in this one. Okay, thank you.